For simplification purposes, this module and the next refer to monitoring practices at a rice mill that purchases ready-made fortified kernels to blend with unfortified rice. Monitoring activities related to manufacturing fortified kernels on site at a rice mill will not be addressed. Internal monitoring refers to the quality management procedures, actions, and tests that are carried out by rice millers to properly fortify rice and ensure a high-quality product for consumers. As a reminder, the two components of internal monitoring include quality assurance, QA, and quality control, QC. Quality assurance is focused on the process of fortification. Millers who prioritize quality assurance want the end product to be perfect, so they implement proactive measures and quality checks throughout the fortification process. Doing so raises the likelihood that the fortified rice will be of high quality, safe, and will meet the specifications of the fortification standard. If you equate fortified rice to a school exam, both as the end product, anything that is done by the student to increase the likelihood of a good grade would be considered quality assurance. Examples include studying, thoroughly reading the test directions, not rushing through the questions, etc. Quality control is comprised of activities that are conducted on rice after fortified kernels and unfortified rice are blended to document that the end product complies with the fortification standard before making it available to consumers. Thinking back to our analogy, quality control is like a student reviewing his or her answers to be sure they are correct before turning the exam, the final product, into the professor. To get you thinking, below is a list of activities that should be labeled as quality assurance or quality control. Pause the video and take a couple of minutes now to see if you can label them correctly. Remember, quality assurance is about the process of fortification, and quality control is about reviewing the end product. Now let's go over the answers together. Note that the numbers refer to those listed on the previous slide. Quality assurance includes using only fortified kernels that are provided by a reputable supplier and are accompanied by a certificate of analysis, storing fortified kernels appropriately and using them by the expiration date, installing and maintaining a quality feeder, regularly checking and recording the fortified kernel feed rate, verifying the amount of fortified kernels used against the production of fortified rice, and packaging, labeling, and storing fortified rice according to the specifications of the country's rice fortification standard and any existing national food code. Quality control simply includes regularly confirming that rice is fortified using qualitative tests, confirming with quantitative analysis that the micronutrient levels in the fortified rice comply with the specifications of the fortification standard. As you can tell, the majority of activities are categorized as quality assurance. And this makes sense, right? The aim should be to conduct the fortification process properly to avoid wasting time and materials. Overemphasizing quality control activities is risky because it's hard to fix the finished product. After the fortification process is completed, you simply want to confirm that the quality of rice is what you expect. For the remainder of the module, we'll talk in depth about each quality assurance and quality control activity. Naturally, we'll start with quality assurance activities. Our first quality assurance procedure is using only fortified kernels that are provided by a reputable supplier and accompanied by a certificate of analysis. Each time a shipment of fortified kernels is delivered to a rice mill, the employee in charge of receiving the product should go through the following steps. Step 1. Assess the condition of the package received. Is there any damage that may compromise the quality of the fortified kernels? Step 2. Review the package details and the certificate of analysis to ensure that the right product was received. Step 3. Record the manufacturer, product name, batch or lot number, and the product expiration date on the fortified kernel intake form, Step 4. Remove and file the receiving label. Step 5. File a copy of the COA. The fortified kernel manufacturer may ship a hard copy along with the shipment, or it may send it electronically. Once the intake procedures are done, employees may place an approved sticker on the box like the one you see here. This is a box of premix for wheat flour fortification, but the same can be done for shipments of fortified kernels. The Certificate of Analysis is a document endorsed by a competent authority, such as a reputable fortified kernel producer, and backed by laboratory analyses. It contains many pieces of information, as you'll see in a minute when we look at an example. Generally speaking, a Certificate of Analysis validates the quality and safety of the fortified kernels. It also verifies that the product contains that which is advertised on the label. For instance, if the Certificate of Analysis indicates that the fortified kernels contain iron, folic acid, and zinc, then a test of the kernels should confirm that. When the fortified kernels are mixed with unfortified rice at the appropriate ratio, the end product is expected to meet the specifications of the country's fortification standard. Now, let's take a look at one together. Here is a Certificate of Analysis for fortified kernels produced by Buehler Food. At the top of the document, you see the product name and code, the manufacturing date, the lot number, the product volume, the expiration date, and the Certificate of Analysis number. The chart includes characteristics of the fortified kernels, the quantity of broken and carbonized kernels, and a list of the added micronutrients, along with the results for each as compared to the respective limits or specifications. At the bottom of page 2, you see a space for signatures from the analysts and the quality manager, along with company contact information. Please note that a universal COA template does not exist. You will notice some variations when you compare this Certificate of Analysis to that of another company. Some countries choose to prepare an approved supplier list as part of the startup process for a fortification program. In South Africa, where there is mandatory wheat and maize flour fortification, regulatory authorities update the approved premix supplier list periodically, and even make visits to international premix facilities on occasion. This list takes the burden of decision-making off of the wheat and maize millers and makes importing premix more efficient. Approved supplier lists are developed by the entity that has jurisdiction over premix, such as a Food and Drug Authority, and should be provided to the millers and border control officials. Countries in which rice millers utilize fortificant blends and/or fortified kernels can prepare a similar approved supplier list. The second quality assurance activity is storing fortified kernels appropriately and using them by the expiration date. Fortified kernels should be kept in a cool and dry storage facility where the boxes or bags are placed on pallets to allow ventilation. They should also be away from direct sunlight. In some cases, a large mill that fortifies a significant proportion of its products may receive loose bulk fortified kernels to be stored in a storage bin. The same principles apply. If storage conditions are not optimal, the fortified kernels should be used within a few months. The fortified kernel supply should be arranged in a way that facilitates using the oldest fortified kernels first. This is called the first-in, first-out FIFO system. If a facility receives boxes or bags of fortified kernels, they need to be labeled. For example, the first batch or lot of fortified kernels to arrive would be marked A, and the second would be marked B. This method supports easy identification. The movement of packages to the production area will start with all packages labeled A, followed by those labeled B, and so on. All fortified kernels should be used by the best if used by or expiration date provided. The third quality assurance procedure is installing and maintaining a quality feeder, ideally one that allows for the delivery of fortified kernels to be tied to the movement of unfortified rice. A feeder is the primary means by which fortified kernels are added to unfortified rice. In these pictures, you see feeders attached to the production line of a flour mill. Feeders used to fortify rice have a similar design, but are much larger. The top portion that looks like an upside-down triangle is the feeder hopper. The feeder hopper is where a designated employee will add fortified kernels, unless a chute attached to the feeder hopper automatically deposits new product as necessary. To fortify rice, mills may choose to use feeders with various delivery methods. A vibratory feeder uses vibration and gravity to deliver the fortified kernels to the unfortified rice. A conveyor feeder delivers fortified kernels using a conveyor belt system. Screw feeders use a screw-like action to deliver fortified kernels. They have also been tested with rice fortification and are a viable option. However, they increase the proportion of broken rice grains in the final product, which most millers do not want. Now that you are aware of some feeder options, let's talk about the preferred way to dose the fortified kernels. All of the feeders previously mentioned, vibratory, conveyor, and screw, can operate as loss and weight feeders if installed appropriately. To do so, the selected feeder will be placed on load cells, which sense the weight of the feeder and of the fortified kernels in the hopper. The feeder is connected to the mill's control system. The control system constantly relays the quantity of unfortified rice in the blending equipment to the feeder. The feed rate automatically adjusts to dispense the proper amount of fortified kernels. The actual operation of the feeder is based on the loss of product weight as the fortified kernels are released into the unfortified rice, hence the term loss and weight. This is recommended for fully automated mills. The integration of fortified kernels with unfortified rice can be done in two ways, in batches or in a continuous manner. For fortification in batches, a feeder can be installed, or a mill staff can manually measure out the proper amount of fortified kernels for each batch of rice. After a set amount of unfortified rice enters the blender, a proportionate amount of fortified kernels is added all at once. The blender is turned on, thus beginning the process of uniformly combining the two items. After the blender stops, the now fortified rice is transported to storage or to the packaging area. Batch mixing is typically used by small to medium-sized mills that produce smaller volumes of fortified rice. Large industrial mills typically fortify rice in a continuous manner. They will need to invest in a feeder if one hasn't been installed for other purposes, but they do not have to invest in blenders specific to the fortification process. Rather, common equipment needed for rice milling can serve that purpose. For example, milling graters or length grading cylinders can blend the fortified kernels with unfortified rice. Fortified kernels are added appropriately and automatically using a feeder. Blending occurs as part of the milling process in an ongoing manner until the mill is stopped. Please note that the feeder must be placed 3 to 4 meters behind where fortified rice is discharged from the blending mechanism to ensure that the fortified kernels and unfortified rice are sufficiently mixed. Here you see diagrams depicting both batch and continuous blending. You may notice that feeder images are not included as part of the batch blending diagram. This was done intentionally to depict that mill management may choose between manual addition of fortified kernels or installation of a feeder for that purpose. On the continuous side, you see black triangles next to the feeders. These indicate that the fortified kernels and unfortified rice are constantly being weighed to ensure proper dosing of the fortified kernels. In many cases, the unfortified rice will not go through a feeder like the fortified kernels. Rather, it will enter the mixing area through a chute or a conveyor from another part of the rice mill. However, load cells will still be used to determine the weight of the product. For mills that utilize a feeder, as opposed to manually measuring the fortified kernels, setting up an interlock system between the feeder and the blending mechanism is highly recommended. This will stop the feeder if the blending mechanism halts for an unexpected reason. An interlock system is one way to prevent over-fortification. Additionally, it is beneficial to install a feeder that includes a low-level detector. This device is located near the bottom of the feeder hopper and will sound an alarm if the level of fortified kernels drops too low. Low-level detectors help prevent under-fortification. Prior to using a feeder for the first time, it needs to be calibrated on site. This can be done by mill employees or by a representative of the company that manufactured the feeder. The first step, as you see here, is to confirm the unfortified rice flow rate. If fortifying continuously as part of the rice milling process, check the unfortified rice production scales and confirm using the check-weigh process if possible. The check-weigh process will be described in more detail in the next section of the module. If fortifying continuously in the packing and loadout area, check the scales on the unfortified rice transfer system and confirm using the check-weigh process if possible. If fortifying in batches, use the weight of the unfortified rice delivered to the batch blender. Step 2 is discharging the fortified kernels at various settings. First, add fortified kernels to the hopper until it is half full. Set the feeder to maximum discharge. Run the feeder for a minute while collecting the fortified kernels. Next, weigh the fortified kernels. Repeat these procedures additional times at progressively lower feeder speeds or percent settings until you reach the lowest limit. Write down the results each time. You will need them for the next step. Step 3 is to make a calibration curve. Using the data just collected, make a calibration curve that shows the fortified kernel feed rate in kilograms per minute at different speed settings from 0 to 100%. The graph can be displayed near the feeder. Step 4 is to determine the target fortified kernel feed rate. For the calculation, you need to have the fortified kernel addition rate supplied by the manufacturer and the unfortified rice flow rate verified in step 1 of this process. Multiply the two to get the target fortified kernel feed rate. This feed rate is expected to produce fortified rice that complies with the specifications of the fortification standard, assuming the unfortified rice flow rate doesn't fluctuate much. Now that you have the target fortified kernel feed rate, you need to adjust the feeder appropriately. Here is when the calibration curve is useful. Let's say you need to achieve a feed rate of 2.4 kilograms of fortified kernels per minute. You find that number on the y-axis and move your finger right to meet the line. Then look down to the x-axis to see how the feeder should be set. In this case, the feeder speed should be set at 40%. It's important for rice millers to install feeders that can handle the demands of fortification with relative ease. The optimal operating range for a feeder is between 30% and 70% of the calibration curve. Since this feeder needs to be set at 40%, it is sufficient for the mill. Finally, prior to starting the fortification process, it is wise to double-check your feeder by running the check-weigh process one time. All feeders should receive periodic maintenance according to the manufacturer's instructions. Performance check results and maintenance services should be recorded and made available for examination by government inspectors. The fourth quality assurance activity is regularly checking the fortified kernel feed rate, also known as check weighing or the check weigh procedure. If a feeder is used to add fortified kernels to unfortified rice, the feed rate should be checked regularly to confirm that the proper amount is being distributed. These pictures show a flour miller conducting the check weigh process for premix manually. The same principles apply to the check weigh process for fortified kernels. Optimally, the check weigh process will be conducted at the start of a shift and every 4 hours thereafter. Each time, at least one sample of fortified kernels is taken over the span of a minute and then weighed. The feeder needs to be adjusted if the result is greater than 10% above or below the target feed rate. Now, let's watch a video that depicts how to conduct the check weigh procedure. This demonstration uses a screw feeder, but it's the concept that matters. Please note that the units of measurement are from the U.S. customary system, rather than the metric system.
Hi, I'm Tyler with IPM Systems. Today, Sean and I are going to demonstrate how to calculate your feed rate for your IPM Systems volumetric screw feeder. You need a scale, a beaker or a small container, a stopwatch, and a calculator. The first step is to zero out your scale so that you don't include the weight of your container that you're measuring the material in the calculation of the feed rate. So turn on the scale, place a container on it, hit the button again to zero it out, and we're ready to go. So we'll turn on our feeder. Once you start the feeder, you'll want to let it run for a brief moment so that it can get up to full speed. Today we'll be taking a 15-second sample, but if you can take a 30-second or a 1-minute sample, you'll increase your consistency. So let me get our stopwatch here. And Sean, you can start now. Stop. So we'll turn the feeder off, and we can place the beaker on the scale. We come up with 5.95 ounces. So we will take 5.95 times 4 to get us to a 1-minute time frame. Then we will multiply that times 60 to get an hour time frame. And then we will divide that by 16 for pounds. And the feed rate comes out to be 89.25 pounds per hour. And it's as simple as that to calculate your feed rate of your feeder. We'd like to thank you for watching this video today. If you have any questions about what was covered or anything else about your volumetric screw feeder, please feel free to contact us at our toll-free number, 855-328-9200, or you can also email us at service@ipm-sys.com.
If the mill has a highly automated control system installed and operates its feeder using loss and weight principles, the manual check weight process, as described, is not as pertinent. Since the feeder is connected through the mill's control system to the production line, the fortified kernel feed rate is expected to adjust automatically as needed. In addition to the regular feed rate checks, these situations require execution of the check weight process. When the feeder is restarted after the production line stops due to a power outage. When the feeder is restarted after cleaning, maintenance, or calibration. When analyses indicate that a rice sample isn't fortified properly. The fifth quality assurance activity is packaging, labeling, and storing fortified rice according to the requirements of the Fortification Program and the National Food Code, if one exists. Mills must ensure that fortified rice is packaged and labeled according to the requirements put in place by the country where the rice will be sold or distributed. Fortified rice should be packaged in a way to maximize protection of the added micronutrients against sunlight, humidity, and oxygen, and of the fortified rice against insect and rodent infestation. The packaging requirements for fortified rice are often the same or very similar to unfortified rice. Label information is for the consumer, so it should be legible and presented in a language that the consumer can easily understand. Label requirements often include an ingredient list, the product batch or lot number, an expiration or best before date, some indication that the rice is fortified, and contact details for the company that produced the fortified rice. Additionally, the label shall display the National Food Fortification logo where applicable. Suggestions for appropriate storage of the fortified rice should appear on the label and inform the consumer to keep it in a cool, dry place away from direct sunlight. Now, let's review some key information printed on a package of rice sold in the United States of America. Just by looking at the front of the package, it is easy to see that the rice is fortified. The term enriched denotes fortification in the United States. You can also see that the rice is fortified by looking at the ingredient list on the back of the package. In this case, specific micronutrient compounds are listed: ferric phosphate, niacin, thiamine mononitrate, and folic acid. This fortified rice is sold by Kroger Company, which is located in Cincinnati, Ohio. It should be sold by April 4th, 2018, and it should be stored in a cool, dry place. Here are fortification logos that have been instituted around the world to indicate that a product is fortified. The logo is placed on the package as an easy identifier for consumers. The fifth quality assurance activity is verifying fortified kernel usage against the production of rice that should be fortified. One way to gauge if a rice mill is fortifying satisfactorily is to conduct a fortified kernel reconciliation calculation periodically. In many cases, this is done monthly. The exercise is relatively simple and does not require any equipment. The data points needed for the calculation include the starting inventory of fortified kernels, the amount of kernels purchased during the period, if any, the ending inventory of fortified kernels, and the amount of fortified rice produced. To give you a better understanding of the concept, let's go through the example below together. A mill has a starting inventory of 10 metric tons of fortified kernels on May 1st. It receives 45 metric tons of fortified kernels in the middle of the month. On May 31st, when the reconciliation calculation is completed, the remaining amount of fortified kernels is 26.2 metric tons. Doing simple math, we can see that the rice mill used 28.8 metric tons of fortified kernels during the month of May. 2,500 metric tons of fortified rice were produced during the same time period. To calculate the actual fortified kernel addition rate, the amount of fortified kernels used, 28.8 metric tons, is divided by the amount of fortified rice produced, 2,500 metric tons. That result is multiplied by 1,000 to get kilograms. The actual fortified kernel addition rate for this example was 11.52 kilograms of fortified kernels per metric ton of fortified rice. Assuming a target addition rate of 10 kilograms per metric ton of fortified rice, or 1%, the mill added 15% more fortified kernels than needed over the course of the month. Now, let's move on to quality control. There are two primary quality control activities that will be covered in this module. The first one is confirming that rice is fortified using a qualitative test. You will remember from the laboratory module that the iron spot test is the predominant method used to confirm that a rice sample is fortified. To conduct the iron spot test, you need to collect a single sample of rice. Recall that one method of fortifying rice is by adding fortified kernels to unfortified rice in a batch blender. If the batch blender allows, a sampling spear can be inserted to collect a single sample after the fortified kernels and the unfortified rice are sufficiently mixed. If the batch blender is a closed system, a single sample can be collected as the blender discharges fortified rice to a packaging bin or storage area. If a rice mill adds fortified kernels in an ongoing or continuous manner, samples are obtained at the end of the production line or from the rice packaging area. As a general guidance, a single sample should be collected at the start and at the end of every mill shift and at least every 4 hours in between. However, for record-keeping purposes, it is important to have at least one iron spot test result representing each client order. If an order of fortified rice is small, time adjustments for collecting single samples may be necessary. Single samples collected at the mill should amount to roughly 250 grams. Approximately 100 grams of this sample should be used for conducting the iron spot test. The remaining rice, or a portion thereof, is placed into a container designated for the composite sample of the shift. The topic of composite samples will be covered shortly. Fortified kernels containing iron will turn dark red after the iron spot test is conducted. Unfortified rice kernels that come in contact with the reagents during the test will generally display a red hue, since unfortified rice still has an intrinsic amount of iron. The iron spot test doesn't reveal if the rice sample is fortified according to the specifications of the rice fortification standard. However, if you know the target ratio of fortified kernels to unfortified kernels, you might be able to gauge if the fortified kernel feed rate is appropriate. For instance, if the target feed rate is 1 fortified kernel for every 99 unfortified kernels, or 1% of the total product, then an iron spot test with a substantial number of dark red kernels is a signal that the feed rate is too high and should be adjusted. After an iron spot test has been conducted, the results are written into a data collection form or a computer database, and that portion of rice is thrown away. The second quality control procedure is confirming with quantitative analysis that the micronutrient levels in the fortified rice comply with the specifications of the fortification standard. Mill personnel do not typically need to collect additional samples for running quantitative tests. Recall that a composite sample for each shift is prepared from a portion of each single sample that was originally collected for the qualitative test. The minimum number of single samples in one composite sample is 3, but typically more are included. Composite samples must be kept in tightly sealed containers. If the sample contains vitamin A, the container must be opaque to avoid light-induced depletion of the micronutrient. At a minimum, the label should include the mill name, the rice variety, unless only one variety is fortified in the country, the client name, batch or lot number, and the date. Periodically, a composite sample of fortified rice should be analyzed for the content of at least a single marker nutrient, such as iron. This quality control activity confirms that the fortified rice produced by the mill complies with one or more specifications of the fortification standard. The frequency of quantitative testing will vary by mill. It is influenced to a certain extent by the mill's product output and by its equipment quality. High product output and older, less reliable equipment will necessitate more frequent testing. The image above just shows a hypothetical example. Ideally, composite samples are analyzed within 1 month of fortified rice production. Results of quantitative tests should be systematically filed to allow for easy reporting, reviewing, and traceability of the fortified rice if requested by government inspectors. Unused samples, meaning those that are not sent for quantitative testing or collected by government inspectors, can be disposed of after the shelf life of the product. Next up, we'll talk about regulatory monitoring, which is facilitated primarily by government inspectors. But first, take a break. This was a long module,